Hi there, this is an update video for the Reprap Wilson TS 3D printer. Today what I'm showing you is a larger version of the TS that I built. One of the most common questions that I get asked when people ask me questions about this design is how easy it is to make the print volume larger so that you can print bigger objects. And what I have done here is I've made a version of the TS that has twice the print volume by doubling the length of the y-axis. So I'm going to show you how I did that real briefly and explain a couple of the little things that tripped me up along the way or things that I had to do to get that to work. So the first thing that I did differently on this version is that I modified the Y-ends so that they would use 10mm smooth rods instead of 8mm rods. I kept the 8mm rods on the other two axes, the x-axis and y-axis, or z-axis, because I wasn't making those any longer. If you were going to do this kind of trick with the x-axis and make it much longer, I think I'd probably upgrade those also, just so that as it gets bigger, you don't want to get to where you can get any deflection in these rods, and a 10mm rod would be a little sturdier. But you'd probably be able to get away with it up to maybe 12 inches, but in this case my y-axis is closer to 16 inches, and I thought that was a good change to make. The heat bed itself is just two MK2A heat beds that are connected together, and these are so cheap now that it makes a lot more sense, I think, to use two of these than it is to try to buy one really large heat bed, and I don't think they make this in this size anyway. What I did for wiring on the two heat beds is I connected them in parallel. The connection points, if you can see here, are in the middle towards each other. So right here they're connected in parallel so that they each get the same current that you would get normally. So as a result of that, there's quite a bit more current load on the power supply and on the ramps board that has to switch that power. And that was one of the first problems I had. I did get a heavier duty power supply, and I'm going to take this over here so I can show you. This is a 500 watt power supply made by Coolmax. The important spec that you want to look for is the 12 volt current, because that's what powers the heat bed, and this one is rated at 34 amps. The two heat beds I think pull 25 or 26 amps when they're on, so that seems to cover that. The more significant issue is getting the MOSFET that's on the ramps board here to switch that power without any trouble. And what you saw me just take off is this is a little heat sink. Put this camera back. So this little TO220 heat sink is something that I got off of a dead board. It's meant to actually solder down to the board, but I clipped that solder lead off and I just press it onto the tab of the MOSFET. And the reason I did that is when I first did this, I didn't do that. And here's a picture of what happened after I think it was maybe 3 or 4 hours of print time, and then it didn't really burst into flame, but it certainly filled the room with smoke, and you can see the damage that happened as a result. So I replaced that, and then I put that little heat sink on. And the other change that I made is in the firmware. I'm going to show you. So in Marlin, if you aren't already using it, you might want to enable PID temperature control of the bed. PID is how Marlin controls the temperature of your hot end. By default, I think the default configuration is that it it just turns the power on and off without any PID to the bed. But if you enable this and then run the auto tune to generate coefficients, this provides you with better control of the bed temperature. But more importantly right now is this next value down here where it says max bed power. If you set this to a lower value than 255, I have it at 192, then the result will be that it won't leave power on constantly to the bed, but rather will limit it to that as its maximum duty cycle, again out of 255. So it uses the same timer loop for the PID of the bed as is used for the hot end. I think it's at like 9 hertz. I hooked up this 10mm red LED here and just made a little clip so that I could see the LED when it's on, so I get some feedback when power is on the bed. And when you have that PID set and the maximum set below 255, you'll see it flicker at the maximum rate, and that helps limit the power through that MOSFET and helps it stay cool. So after I made those changes, the current wasn't a problem. It still is not real fast to warm up both heat beds, and the big piece of glass that's on top sucks up a lot of heat. So, and another change here, let me mention on the y-axis that I used this time, I used an HTD3 timing belt. It's a heavy duty belt. I wasn't sure if I'd have much issue with the GT2 belt stretching because it's so much longer and because it's moving more mass. Plus the pulleys that I have for HTD3 have kind of heavier grooves because they're 3mm apart instead of 2, so they put a little bit more tooth into the pulley. You'd probably be able to get away with GT2 if that's what you have, but I think this is a good choice if you have it. The MDF sheet that's underneath here is the same width as on the regular Wilson, which is 23 centimeters, and the length is for 40 centimeters, so 400mm. But what is different besides the size is the location of the bearing holders. So let me explain. Usually the end stop at the motor end hits the edge of the bed right here. But if you did that, if you allowed the end stop to hit here, then you can see how much area is in front of the hot end. So you'd have to move the entire upright part of the frame way forward, and then in order to get to the back, you'd have to have it travel way out in front, and you'd end up with the bearings clear back here with nothing underneath the front of the bed. It wouldn't be very stable. So the bearings instead are closer to the middle, but in order to get that to work, you have to cut out the MDF so that end stop won't hit. And I'm going to show you over here. This is a little drawing that I made of how the MDF wants to be cut. So you can see it's 400mm by 230mm, and then on the idler end, so that's the front usually, instead of 8 centimeters from the edge, the bearing holders are 12.5 centimeters. And then on the back side, you cut this notch, the end stop will actually strike back here, and then those bearing holders are 1 centimeter from that inside edge. And here's a photo. You can see what the printer looked like before I put the heat beds on, just to further explain that part. Another thing that is different on this model that I want to explain, it doesn't have to do with the longer y-axis, but the Z motor holders. If you look closely, you'll notice they now have an extra screw hole here in the front. I added just this little piece of bit of material, and on the last video I would have shown you a method for supporting the upright frame is to put another piece of T-slot at 45 degrees behind that side, and that works great, but it does require an extra piece of T-slot, a couple more T-slot nuts, and 2 more printed components. And I thought I would give this a try because it doesn't require any of those, it just requires 1 more screw and a nut. This is a prototype, meaning the first time I did it, and it's only a 3mm hole, but the version that is in the repository now has this expanded a little bit, so it'll take a 5mm screw, which is the same thing that I'm using back here. So on this one, the 2 Y-ends are not attached to this deck. The only thing that's attached to the deck is this point and this point on each side, and it's very rigid. I think it works just as well, or nearly as well as the piece of extra piece of extrusion, and without needing any extra parts, I think it's a better idea. So, and it costs almost nothing additional in terms of plastic. There's just a little bit more, maybe 10 grams more plastic on each Z motor holder. So that's what that's all about. On this, when I built this one, I got this full graphics controller instead of the 4-line smart discount controller that I've used before. I wanted to try this guy out. It's got a SD reader built into it just the same. I'm not that impressed with this as a user interface. I don't think it's any better after having used it than the 4-line. In fact, it has some drawbacks in my opinion. The first is it's harder to compile Marlin to use this because you have to have additional libraries in your Arduino compiler path. And secondly, the actual interface when you're navigating menus is more sluggish. I think it's just because there's so much more being drawn on the menus, and it's a graphical display. So I don't think it doesn't really add that much, in my opinion, to the usability. So I think I'll stick, in the future, I think I'll stick with the 4-line display. The other thing, and I'm going to try to lower the camera down here so that I can explain. The other thing that I had to figure out was how to support these 2 heat beds. And when I first set this up, I had 6 screws. I had the 4 corner screws and 2 more here in the middle, all with springs, just touching the bottom of the heat beds in the middle and then through the corners. And then I clipped the glass onto the 2 of them, and that did not work very well at all. The glass actually bends just a little bit right in the middle without anything supporting it, which was kind of surprising, but we're only talking about 1 millimeter or so. It was enough to mess up the printer. And it was harder to level because you've got these 6 points, and finally it couldn't take any kind of stress. Whenever I'm trying to remove parts after the print, the glass would crack. So what I came up with is I bought this aluminum little beam at the hardware store, and it's just an angle iron profile with 3/4 inch by 1/2 inch, and the whole piece I think cost $4. I cut it in half, and it was just about the right length then for each side. I drilled a hole on the corners to match the heat bed, and in the center there's nothing. It's just the heat bed sitting on these 2 rails, and that has worked really nicely. And it's actually easier, I think, to level than a single heat bed, and I guess because there's so much more, you have finer control when you adjust like this corner down 1 millimeter. You know, the distance gets spread out over a larger area. I don't know if that makes sense, but it does seem to be easier to adjust, and it stayed very level. I've got an example. Here's kind of thing that I was printing to test everything out. This is a arm for a quadcopter design that I'm playing around with. Take this motor off. So this is about maybe 12 inches long. I could print a longer one, I guess, on here, but it's nice to be able to print occasionally. I'm not a big fan of gigantic prints because they tend to take a very long time, but when you got something like this, it's relatively small but just has one dimension that's long. It's really nice to have that extra space. So that has worked out nicely. And I think that that is all of the update that I have to give you today. If you have any questions about any of that, then shoot me an email or something and I'll be happy to try to help. I know that larger print volumes are a popular topic, so hopefully this will be of some help to somebody. Thanks. There is one more thing actually I forgot to mention that I want to show you. When I did the 10mm smooth rods on the y-axis, I needed new bearing holders, and so what I did, instead of modify the older style that uses zip ties, is I made a bearing holder like this that would retain the same vertical space this way, so that the sheet that sits on top of it will still ride high enough that it'll clear the Y-ends. But this is just a press fit connector, and this is actually the 8mm, the version for the LM8 UU bearings. So there's two versions now in the repository, and it works really nicely as long as you don't try to force it down over the bearing, but slide the bearings in from the side. And you can do that before you even put the bearings over the rods if you'd like. If you forget and you put the bearings on, then you can still get the holder itself. The slit is wide enough that you can still get it down over the 8mm rod and then slide it on from the side of the bearings. But I like those better. Fewer zip ties. Alright, that's all.